Hello and welcome to this tutorial, which will be about the deck placement analysis of a multi-girder system, a plate girder system. So we have all these parameters here. For this bridge, we have 4 girders. The length is 350 feet. The spacing is 10 feet. And this is an important form if you've seen it for the first time. For placement analysis, you would enter here the deck elevation as the ordinate of the mid-depth of the concrete deck. The deck thickness here is equal to 10 inches and the left overhang and right overhang are 4 feet each. The material properties are standard. We're using a 4 KSI concrete for the placement analysis. This will inform the stiffness that the software will implement when running this placement analysis. We have 3 supports. The pin supports it's at the center, and then we have roller supports at the ends. This is the same for all girders. We have 2 splices, expecting a thicker flanges in a negative moment region here. We have 15 stiffeners. The spacing is 25 feet, so you can use this form, to fill all these columns pretty automatically. You can also copy and paste from Excel if you want. We have 15 cross frames. Now the stiffeners are defined, so we can attach these cross frames onto the stiffeners. Again, 25-foot spacing. These are the areas for the cross frames as usual, and no lean-on bracing, so all this here is 0. We are defining 3 pores within the analysis. So the first pore by default will be 0. I can't change this. But then the second pore will occur 8 hours after the first pore, and here on purpose I'm waiting 40 hours between pore 2 and pore 3 in order to really show you the effect of this and how the deflections will be unbalanced. Okay, so pore 1 will go from 215 feet to 350, so that's the far end, and then the other end here from 0 to 135, and finally the negative moment region as usual to avoid early cracking between the splices, so between 135 and 215. I can store the reference points, but the model's already run, so I don't need to do that again. This is the mesh size, 3 feet, which is pretty standard. I have 2 profiles, one for the positive moment region, one for the negative moment region here. The negative moment region, I have profile number 2, same for all 4 girders. This is pretty default. We have constant web depth, so all you need to do here in this form is to click on the default button and these columns will be automatically filled out for you. It's of course the same for all the other girders. This is also pretty standard. These are the default values proposed by the software. We have a stud spacing of 1 foot, 3 studs per row, and a stud diameter of 3/4 of an inch. This will really inform the stiffness matrix for the links which are implemented at each node between the steel superstructure and the concrete deck, and we have a time-dependent stiffness matrix for these links. So this is something pretty unique. We believe in Embrace 3D to be able to capture the partial composite action as the concrete deck stiffens. It's neither a full composite action or an independent action between the deck and the steel. So this is quite useful here, we believe, in Embrace 3D. We can run the model here, but it's already run. So let's go to the viewer, and we can see here, if we zoom out, we can see the properties first. We can also look, of course, at stage number 1. So the concrete is placed on that side, pretty large deflections. Then stage 2 here, and finally stage 3 on the negative moment region right here. Now, something interesting we believe is we can check cross-frame forces pretty automatically. You can get all these forces automatically. Something else is that if we look at the displacement chart, you can see first stage number 1, of course, this end will deflect, but then stage number 2, it won't deflect as much because the far end is already stiffening that portion. So we have a differential deflection here between span 1 and span 2, and that's due to the fact that we have partial composite action already acting on that side. So I believe this is helpful, and thank you very much.